Welcome to the third part of the Chem 110 calorimetry experiment. All right, in part 3, what we are doing is finding the specific heat of an unknown material. So we're going to accept that we know the specific heat of water, and of course we can measure all the masses and everything, but we're going to use that specific heat of water to kind of ratio some unknown against that. So straight away we do a similar start. We're going to take our calorimeter, add water to it, weigh it. Let's say we had 74.66 grams here. We're going to have water boiling, and then we keep the solid dry by putting the solid in a large test tube and just setting that test tube in the boiling water. So we don't actually measure it directly, but since the water was boiling at 98 degrees, we will say that the solid came to that temperature as well. All right, so that's our boiling water, and then our calorimeter is going to have 60 or so grams of relatively cool water, room temperature water in it, and we'll say that started off at 25.0 degrees Celsius. All right, so we're going to take the 98 degree solid, and we're just going to dump that into the calorimeter that already contains water. Initially, we usually see a spike in temperature because the thermometer is resting on the bottom of the calorimeter where all the hot metal sinks, and so it shoots way up. But as we swirl it around, that temperature comes down to a nice stable temperature, hopefully a little above the 25. In our experiment, we got 31.1 degrees Celsius for a final temperature. So this value here, we don't really care about. We're just kind of watching it, seeing what happens. This is the one, that final temperature that we really care about. All right, once all said and done, we weigh our mixture, and we see that we had 95.77 grams. So this will be the calorimeter, the solid that we added, and the water that was in there originally. All right, pressing on with calculations. Part 3. The mass of water in the calorimeter is found exactly as we found it before. We had the calorimeter with the water, 74.66, minus our 7.5 gram calorimeter. And so the water that we put in there is the difference, or 67.16 grams. All right, the mass of the solid, that'll be the final mass, which we had was 95.77. And we're taking away the 74.66. And so we're saying we had 21 grams of solid. All right, temperature change of the water. There's another one of these goofs that's supposed to be over there. My temperature change of the water, delta T, is T final minus T initial. My T final was 31.1 degrees Celsius, minus my initial temperature of water was 25, equals 6.1 degrees Celsius. It's important with this one that we measure things to the 10th because we typically lose the tens place in these small temperature changes. And if we didn't record to the 10th, we'd only have one sig fig here. So 6.1 degrees Celsius. Temperature change for the solid, same idea, delta T equals T final minus T initial equals 31.1 minus our initial boiling water, which was 98.2. And so I have negative 67.1. And again, you don't need to put the negative sign there. We're going to drop it in a sec. All right, energy gained by the water. Who can tell me the equation? And yes, you have to rewrite it every time, trials 1 and trial 2. So mass times specific heat times delta T. Our mass here was the 67.16. Specific heat is again referring to water, so 4.18 joules per gram degree Celsius. And our delta T was our delta T 6.1. Grams cancel, degree Celsius cancels, and I get, what do I get? I get 1712. All right, so that's how much energy was lost by the water when we added the hot metal to it. We don't calculate this energy lost by solid. We're saying that, oh, if the water gained 1700 joules, then the solid must have lost 1700 joules. Okay, and again, probably 3 sig figs there, 2 sig figs really, 1700 joules. All right, so we're just going to carry that number down, whether we call it 1712 or 1700. That's our value there. Okay, the specific heat now is calculated using the same equation, so I like to remember it as that energy is mass times specific heat times delta T. But in this case, we're trying to find the specific heat. So we solve that equation for specific heat. Specific heat equals energy over mass times delta T. And now plug in the actual values that we calculated earlier on the page. The energy was that 1700. The mass is now referring to the mass of solid, which was 21.11 grams. And the delta T is also referring to the solid, so that's going to be my 67.1 degrees Celsius. And numerically that is, what do we get, 1.21 joules per gram degrees Celsius. And just taking a look at those units again, I got joules, I got grams, and I got, degrees Celsius, giving me what I need there. Sig figs wise, that energy was really limited to 2 because of the delta T associated with water, so we'd legitimately only be able to have 2 here as well. And there we have it. And like as with part 2, our specific heat in trial 1 should be fairly close to our trial 2, though the data that leads to that, the masses and whatnot, just are what they are. But when we do the ratio here, that ratio should come down to something close to this. Specific heat of water is 4 and change joules per gram degree Celsius. It's higher than any other common material. Most materials we'd be using in lab for this experiment would have a specific heat of around 1 joule per gram degree Celsius. I think aluminum is roughly 0.9, silicon is right around 1, so it's in that ballpark. All right, so that's it for the data and the calculations. Now we have the fun of doing some sort of a write-up. So what should we do at a write-up for this lab? Obviously, we want the data and calculations to look good, especially the calculations. That's our practice. But the other things we can do here is take a stab at the questions that are in the packet, and definitely the errors. You can make stuff up even though you didn't do the lab, but that really demonstrates that you had a pretty good idea of what's going on. And I guess before you do all that, so I'll put a little star up here, do a second trial. And with the second trial, make up the data. So go through the data that I gave you, which is reasonably good, and just change those numbers, ballpark by plus or minus 10%, okay? And what this means is that everybody should have unique data and thus results for trial 2, okay? So if you got somebody that's a friend in the class, talk about it, figure out the meaning of life and all that, but make sure your calculations and your data are yours and yours alone. And then lastly, your individual lab instructor might have directions for what they want in terms of instructor instructions. There we go. Okay, but as a minimum then, again, go through and just make up a second round of data, do your calculations, and then answer the 3 questions that are part of the lab, and as usual, come up with errors as to what the problems in the lab might have been. All right, with that, I will sign off and have a good weekend.